Let's get started, and I will bring on Rich Friedman. Hi, Rich.
Hey Chris, how you doing?
Good, good. So, Rich is a co founder and the architect of Redline 13. And with that, I'm just going to let Rich get started. So, I will share your screen out, and there you go, Rich.
Great. Thanks everyone for joining today. I kind of wanted to cover a topic a little different, still bringing it in about load testing, but talk about kind of a recent journey into kind of some emerging technology and what I've learned, and how to kind of even take some of those insights and kind of how I related them back to things I do in performance and load testing. And so the title is "Don't Turn Your Load Test into an NFT and Other Things You Should Never Do." For folks that haven't tackled Web3 yet, I will walk a little bit through a little bit about it, tell you a little bit of information about like what it means to do performance testing so far in this universe, and maybe we could talk a little bit about what might be coming. So I'll start off with just what is Web3. There's this word being bandied around. Web3 is typically focused around kind of this distributed architecture. People will talk about the blockchain. And the blockchain has advanced into things like smart contracts, which to me are really contracts with code. It's kind of like it's near JavaScript Solidity type language. And then there's crypto to pay for the actual processing time. And we'll talk about some of these pieces as we go through. The other part that people talk about, which is really not focused around this part of Web3, is also like meta and virtual reality. That's a different part of the universe. So this part of the universe is kind of like this very smart ledger, this global database that can hold numbers, strings, code, and execute it in this distributed way. It's very unique. It's like taking a single database and just kind of running it at global scale, and all the things that you can imagine that come along with that. So I'm kind of jumping really fast from like blockchain into this thing that is happening every day that people are kind of exploded on the internet. People are talking about this thing called an NFT, a non-fungible token. I'm not going to teach about non-fungible tokens and the details. I really want to focus on thoughts around load testing and performance testing more so. But this one thing that came up is, does an NFT actually exist on the blockchain? Because you hear about this blockchain as this thing where it's guaranteed, I own this asset. In reality, these digital images that are floating around don't actually exist inside the blockchain. There's a record that you own, sort of, this URL in most cases. And that URL could be anywhere. So the actual thing that you think you own doesn't actually exist on the blockchain. It's a kind of like a reference to it. Unfortunately, that reference could change. And people have shown that they've done this, where people have bought something and then the image changes because you can upload a new image, or you can put it behind a URL that generates code. So it starts getting, to me, a little interesting about kind of like what's the architecture in this kind of Web3 world, and is it completely separate from Web 2, where we're used to client server type applications, or from your desktop or from your mobile app? And how do these things interrelate? Because in the end, the NFT in this case really is two components that we're going to talk about. And that is, one is the contract, this smart contract that exists, which is the thing that kind of generates it for you. And then later on, you interact with this contract. So when an NFT really first goes up, this contract goes up, which knows how to build the NFT, sort of. And then later on, the people that, when you mint an object, you're actually using that smart contract to generate another item on the blockchain. And so that's the code that runs. Does that code need to be super fast? Does that code need to be tested like 1,000, simulating 100,000 users minting an NFT? So what does that mean in this blockchain universe? What are we actually testing? So one of the things, as soon as you start building in this universe, you're going to realize that you don't have control, especially when you're talking about things like Ethereum or Bitcoin. You don't exactly have control over that global database. unless you're working on like the core layers of it, you're not going to be able to say, all right, I want to speed that up from 1 million transactions a second to 2 million transactions a second. That's kind of like working groups and a whole different part of folks working like at the operating layer of blockchain. And so there's a lot going on there where they talk about proof of work, proof of stake, and it's a whole universe. I'm going to be focusing kind of on the layer above for us who build applications or want to interact with it. What does it mean? So what you get hit with very quickly is that there's a cost to do this, very different than what we're used to in the Web2 world. And I don't think that really gets talked about enough when you read about, oh, I'm going to mint an NFT. Well, so how does, or what is the costs behind all this actually mean? So here's how it works. Underneath it, there's this thing called gas. This fun expression that basically that's how much it costs to do things on the blockchain. And it costs a certain amount of gas to store things, to execute that code. Each operation has a cost to it. You want to store memory, you want to add two numbers together, you want to generate a URL. All those things actually cost every time you run it. Even just to push the contract up and store it costs money. And it gets reflected as what's called GUI, which really is which is 1 quintillionth of a single Ethereum. And the GUI means a gigaWi. So that's kind of like the base level, how it gets in there. And gas is actually a price that it's the going rate of doing something, the going rate of those operations. And the interesting part is gas prices fluctuate. So how much GUI is gas right now will be a different price like in the middle of the night than it will be during the day. And so these has different costs. You have to think about that as you start to build these things. And they will fluctuate. Right now, I was watching yesterday and it was running anywhere from 130 GUI to 170 GUI. And so, okay, how much is a GUI? It's about, GUI itself is 1 to the negative 9th Ethereum, and at roughly $2,700 where it was yesterday, it's, 0.0000027 cents. So that doesn't seem bad, except you start realizing that it costs just the initial part of interacting costs 21,000 gas. So 21,000 gas times, if we're doing it at a certain time, 170 GUI, ends up being $9.64. Okay, so every time you deploy code, it's going to cost you $10. So for folks that are used to just like continuous integration, continuous builds, continuous deployment, that's kind of weird. We're not used to that. We're like, yeah, deploy more, build more often, execute more often, throw the code up, do a beta, right? That's what we spend time building flag-based systems so we can put betas up. And if it causes a bug, turn it off, go back to this, or start another experiment. How many experiments for folks that build normal systems have, tens, hundreds of experiments going on at the same time? You kind of don't want to do that if every deployment is going to cost you $10. So you could start getting into, this is where we need to focus on as performance engineers, because remember, it's not just the base cost, but then there's cost of operations. So storing the contract, all the code that you're going to push up in your contract, which gets compiled down, but all that stuff ends up costing you money. And so it could easily cost you $200 to deploy something, and not just the base cost. And then you have to execute that contract, and that still requires the base costs and then an execution. So of course, people have gotten smarter over time, and they have like something that goes up that can execute multiple to reduce their costs. And so as people learn it, they're getting more, they're adapting more to the architecture underlying it. But you could see as performance engineers, what we're going to get asked about is, well, I need this to be really performant. And not only is it performant, but I need it to be accurate. So think of testing holistically. I need to test this contract so I know that it's going to be correct. Because, all right, I deploy it and it has a bug. I put it into my stage environment. In this environment, it's going to cost you money. So it gets interesting underneath that. There's really good tooling to actually test your contracts locally. And so you could run through that all day long. So you can give yourself Ethereum, but it's all in your local environment. It's fake. And if you really want, and I'll talk about it, I think, a little bit later, is there's also great resources on AWS, for example, the AWS managed blockchain, where you can bring up your own environment. So there's plenty of opportunity to test, but we all know that issues get into production, and we have to redeploy again. But you also really want to fine tune testing the performance, the number of operations you're doing, especially if it's going to be a contract that's going to run for many times. Now, I know that there's, like, when you deploy these contracts, they have some meta information, like you could set the gas limit. So I don't want to spend more than 4 million gas, whatever that ends up costing you. So you could set your limits, and you can do things about like how often it gets executed and pieces like that. But you still, once you execute it and it goes beyond that 4 million and it doesn't finish, you still get charged the 4 million. It doesn't say, oh, you didn't finish. People had to do work. So when they have to do work, they charge you. And so all that cost behind there is what you hear about when people mining or creating the chains or writing the blocks. That's all the work they have to do. And why is it so expensive? Because, a deployment for me through Jenkins into AWS costs pennies. It's because it's a globally distributed database at scale. There are people writing to this multiple blockchains, these nodes kind of throughout the kind of global internet. And so all that actually costs a lot of work. And that gets into this whole thing where people are talking about, oh, is this worth it because of how much energy it uses? But that's why these prices keep going up, and it's not easy to do things. So we need to focus on performance testing at the contract level. How do we make it so it's accurate, it's efficient, and that it will end when we need it to, and that it won't kind of continuously go on? So we need to test all those use cases and all those scenarios and constantly monitor its performance. That's a big part of it. And so a little bit more on performance on the blockchain. It's, Ethereum is a global database, over 1 million transactions a second. And, there are ways that you could build private networks, like using AWS managed blockchain. But in reality, most of that technology is out of your control. And it's not exactly like a database where you're going to tune the query. In this case, you're tuning the contract, if you would. But a query, a lot of times, you'll put it into production, and then you'll look at the logs. And as it scales, you'll look for bottlenecks. But here, you start running those contracts, it gets very expensive out there. So you're going to be monitoring it up front very quickly to make sure there's nothing going wrong with it. And you'll do those things up front. Otherwise, bad consequences. But you're not going to be able to control the transaction rate of the global database. But there is work being done at the core Ethereum level, at the protocol level, to actually improve that. As you noticed, a gas-based approach is expensive. Performance, not load testing, is important. You're not load testing what happens if 1,000 of these run at the same time. You're performance testing how well does one run. And that is an important part of this universe in terms of contract-based performance testing. But what you'll also see, and this will be true, in my opinion, for quite some time, that the Web2 meta virtual experiences are going to be in front of the chain. Most of your interactions, unless you're actually at the contract level, kind of building that, or really at the Ethereum level, you're going to be doing traditional testing. You're still going to have 1,000 transactions, thousands and thousands of transactions if you're building high-scale systems, or millions of virtual users, and what percentage of them are going to interact. So if you're building an application, and that application is going to enable your users to mint items, right? You're going to be testing the basic flow of that application, and you're going to deal with the performance of writing it to the blockchain. And so, but you'll still be in the traditional experience of testing, load testing, performance testing, but it'll really be on the Web 2, so to say, parts of your infrastructure. So how I got here was this, getting a deeper understanding of Web3, the blockchain, starting to write some contracts and learning, and then having to performance test. And so, as you start getting into this space and not understanding the price of gas, you get these ideas. Wouldn't it be cool to make a smart contract that could distribute load testing? It's code. Maybe I could do something. This could be kind of cool. So I can democratize the efforts of load testing and distribute the cost. And then you realize this is really expensive. You can't distribute load tests when it costs, this amount of money, 21,000 kind of even to do a transaction. How are you going to distribute all that load testing? So democratizing load testing really didn't seem to make sense, even though you get caught up in the momentum of NFTs can be everything. It's different than just kind of open source technology where you can write code, or just what the cloud did and made it so we could just deploy code everywhere and really run things cheap. This is different until they figure out the future and can really make it a platform where the costs come down. It will have certain limitations. So personally, for performance test, for load testing, I'm going to stick with the things that we've built for Redline, with spot instances and on-demand instances on Amazon. We've run 100,000 user load tests for dollars over and over and over again. So I think we've done an amazing job, but we're always on the lookout for new technology and interesting ways to make sure we could scale load testing. So the next little piece I want to talk about is, so these are things I learned kind of going through this process of evaluating this emerging technology, but it also made me reflect a little bit on things we've learned in performance testing and in load testing. And so what I started thinking about is, what else has more cost than you expect? We've kind of went through this, and I've gone through this multiple times with even just in traditional load testing. And I want to highlight some of those cases today. So things, load testing insights you can use today based on understanding like cost and running lots of load tests and load tests at massive scale. How does that translate? So some things that kind of parallel the cost piece, we just don't think about it in terms of gas, is one, browser-based approaches at scale. It's hard and it costs a lot, just like it costs gas. So we have a ton of folks who come and ask, I really want to run a load test. I want to do it at scale. Can you guys support 100,000 virtual users, 1 million virtual users? Of course we can. And then they start saying, okay, I have the Selenium test and I just want to run it for simulate 1 million browsers. And we kind of have to give them a little bit of reality with that. And we can, and we've had people who've scaled up a few thousand, but it becomes very costly. Why? And that's because a browser is an expensive thing to simulate. Even with headless browsers today, it still is not cheap. So it costs CPUs. So instead of gas, it costs CPUs, which is really kind of what gas is representing in that distributed blockchain, right? So you can't just say, I want to run 1,000 browsers on an M5 medium or large or a T class node in Amazon. You're gonna get one browser per CPU, and even running multiple on those, it's a lot to coordinate that, and so there's a lot that goes on. And then you're also paying the cost of, okay, now I'm not just loading up APIs, I'm loading up JavaScript that has to run, so the JavaScript engine has to go, everything else that the browser has inside of it. And then you're getting assets that those assets are not really load testing anything for you. So we learned a long time ago, because we thought it was a cool feature, just like I think NFTs are cool, to support Selenium. And so people use it, and we encourage it at like some small scale, a few hundred or something like that. But it's really important as you get into load testing to extract out the actual APIs that you want to load test, and figure out how to script those interactions, get around some of your limitations. I know it's a lot easier to just say, oh, I want to spin up some browsers because I have my Selenium tests. understand that. But we haven't, and if people know of it, love to learn. We're always poking at that area, but haven't found a way to truly scale that out without the cost of the browser. So it costs gas, if you would. It costs dollars to run those browsers, and then it also costs a lot of interaction there. So we could simulate 5,000 users on like 1 or 2 servers, but 5,000 users for Selenium is going to be maybe 5,000 nodes, or 5,000 instances, or maybe 2,500 instances, or something like that. And that's all. Then again, now you're sending a lot more data over, and it just expands the footprint of the load test and will cost you more. The other area that you learn quickly in load testing that's also related to costs and gas is spinning up test environments. So you're always having to figure out what is your sorry, looking through the comments. What is your test environment? So you want to replicate production. It turns out that gets expensive. And I know at places that we do performance testing at some large scale, it's very common because it's kind of baked into their process, and they absorb the cost of running a either almost near production environment or a slightly scaled down version production environment. And that has costs. I've seen it, run 50-70% of production costs at times, especially when you're doing heavy load tests. So it's expensive to do that. Sometimes you just have to take that. There isn't always a way around that. But I think people have learned a lot over the years and realized that they can figure things out. And the following is something, you might not exactly be able to do in the NFT universe, but it's how do you do load testing in your production environment? So, the immediate reaction we get from engineers is, well, you can't do that because you're going to affect users. And that's true. But sometimes you want to do that. You want a performance test in production because you need to simulate what happens when things scale up or down. And unless you're running a performance environment that is 100% fully optimized 24 hours a day, there probably are bands of windows where you actually could run performance tests on prod. Maybe not 2x, 3x scale tests. Maybe those you have to reserve, but there are ways. And we see people doing continuous testing on production environments. I call them kind of micro tests. So we have people who literally every day for like a couple of years now who have like probably Jenkins jobs, or where they're using our APIs to actually hit their production environments for 5-10 minutes at burst scale. And then they get their results and they validate that, nope, nothing big on performance side has changed. So I see that as a encouraging sign. It also sometimes forces kind of like your upscale, downscale triggers in like if you're using AWS or Google Cloud, or whichever cloud environment. And those things have an impact and worthwhile to see what they do to your environment. Because we've literally, I have found organizations kind of find this out in production anyway, which is what happens when I upscale. Oh, it scaled up, but it took a while. How long does it take for all my users to kind of switch into that? Or what does that mean to performance? And then the same thing on downscaling. We've seen events happen in downscaling that we didn't anticipate. So kind of learning from that you can do some of these tests against your production environment, especially with things like automation and Jenkins jobs and scheduling, that really can have a positive impact on reviewing your architecture. That's what I wanted to cover, kind of going from an emerging technology and getting excited about it to kind of the practical thing of hopefully gave you a little knowledge on gas. And I see somebody wants us to set up a gas station. But yeah, it's you do want to kind of figure out if your algorithms are efficient. But also hopefully tied it back to, we think about this when we do performance and load testing and what's the cost. And we do, that has modeled into load testing and performance testing. So Chris.
Yep. Great. Thanks, Rich. Yeah, let's go over a couple questions. Let's see if we have any questions from the audience here. I guess as I was listening here, I mean, if companies are not yet doing things, like Web3, emerging technologies, is there anything they can be doing, and how far off do you see that happening before that's, hitting more and more people?
Um, so it's an interesting piece. I've seen it come up in different customers um, asking, what can we use it for? Some trying to ride the buzz of it. Others trying to figure out how to integrate it into their products. And I think what I see is a lot of people asking the questions now. How is this going to, how can we leverage this? What is it going to mean? Now, I think that there are, in certain kind of, if you break it down into like, what is finance um, uh, doing in blockchain? I think there's a lot going on in that space, in financial companies, banks, investment companies. I mean, look at what, Coinbase and Robinhood and even PayPal. Like, everybody is doing things around Ethereum, and they're going to, while they're doing things you see on the financial side, they're also doing a lot of investigation on the contract side, which is really related to this performance testing. So I think there's a lot going on in certain industries, and I know you might not see this in if you're doing IoT type things, or you're doing industrial work, you might not see NFTs enter for, you might not see them enter. But I know in companies that are doing things with more community-based, social type things, that you are seeing this question come up and people investigate it. So I think you can, I think you are seeing this. How much of it goes to prod? I think people are going to experiment, deploy things, and figure out what sticks with users. It's really an emerging technology that people haven't figured out all the use cases for. So I think that's happening now.
All right. So, Rich, I'm going to hear some questions from the audience. I'll post it right here so everyone can see.
Yeah, so there are ways. It gets interesting. There's multiple ways to kind of deal with gas. Like, you can run on different networks like Solana and other pieces. It doesn't all have to be on Ethereum, right? So there's other ways to deal with it. And there's other networks trying to reduce that cost of operations. And there's looking at what time of the day and coding your stuff to be when you do your deployments or when you execute your contracts. And then there's other kind of token mechanisms that are trying to kind of deal with that. I haven't used gastoken.io to reduce costs, but I know there's a lot going on to achieve that.
All right, great. And here's another one.
Really, really good question. So what do I mean by microtesting in production? So I mean running like a 10-minute test off time, off peak. So you want to basically hit up what happens if I get a burst of this interaction over 10 minutes. So I want to test it, and I want to make sure I'm testing it against an environment that looks identical to production. So instead of spinning up a production environment, if my tests run it off peak, I can actually use my production environment. Now, you might have to build some of this into your architecture, meaning you're not going to use real user data. So you might have a set of your test users that you use to simulate this. I know in a lot of the systems I build, we have like a group of test users that have flags that don't get seen by everybody else. Now, a lot of this depends on the type of application you're doing. Some applications might be easy to simulate in production, others not. I've run systems where we tap production and we run a dual effort, even against prod. So like, let's say I view a page that triggers an event that I can use to simulate my load test. And so I kind of almost like playback. Other cases, I just have a set of users that are marked invisible that we execute just scripted load tests, JMeter test, a scripted load test, and we do it at scale off peak. So it doesn't impact our real users, or hopefully it doesn't, or we're monitoring it, and we're getting real sense of what it's doing in production. And we have customers who literally schedule that and run these tests every day. So think of it as kind of like a health check, a performance health check that they run every day. And that is kind of like what I call like a micro test. Rather than running a load test for like an hour, you're running it, 5-10 minutes. You can run it longer if you have, depending on your off peak, and getting the results. And what's nice about that is those results could show up in your regular graphs that you're used to looking at. So your performance engineers, your operations people, everybody can see the impact. And then if it ever triggers kind of off, the next day you can work with your operations and your development teams to figure out what happened, what changed in the environment. Cool.
Rich, we have another one here in chat. I can't post this one, but it says how to trigger a possible performance issue with such a small time period.
High burst. So it's and also, so two things. You're triggering it, so you could scale up and scale down very quickly. There's nothing preventing you from running we have people who run 5-minute load tests with 50,000 users. When you scale that up, for example, on Redline, right? You just say, I want to run, 10 servers, and it'll kick up. And because you're scaling that load on like 10 load agents, hitting your environment, it will scale. There's no issue scaling to that quickly. If you need to run over a half an hour, I mean, it really depends on what you can do in your production environment. So you might need to scale it up over a half hour. It kind of depends, but then you will see the impact. And what that also allows you to see is code changes that have rolled up. So if I roll up code today, and then I can performance test it on prod through the night, I can actually see, what changed. Because in a cloud environment, some of the changes that happen can be things scaled up, scaled down. So what you're really doing is validating that your production environment hasn't had any changes. So for example, in one of the production environments I work in, I can't even tell you how much config we have, like thousands of config variables. And we have probably like 20-30 people that make config changes. We log all those config changes so you can see the log of them, but any one of those config changes could have a performance impact. And we don't performance test every config change. So by running these micro tests, we can actually see, did something change during the day? And now our performance isn't working the same way we thought of it. So that's why we do that.
Great. I thought there would be a lot of questions. That was good. So, Rich, thank you very much for joining today. And all right.